So let's look at a couple more antiderivatives. So again, looking at the name, antiderivative means we are undoing derivatives. So we're going to go ahead and work backwards to find some of these trig ones. So let's let capital F equal tan x. So think back to differential calculus. F prime would be, right, exactly, so secant squared x. So that means if we integrate secant squared x dx, we get out, right, so we go one way and we get the derivative. So if we go the other way, we get the antiderivative. And it should get you right back where you started, except for, right, that plus c, because the derivative of the constant would be 0, so this would get you right back to the secant squared. Okay, so what if f was secant x? F prime would be, right, secant x tangent x. Therefore, right, the integration version of that, we integrate secant x tangent x dx. You have to have the dx there to let everybody know, right, who's playing the variable, what you're integrating with respect to. So the integral of that derivative gets us back to the original function. Again, plus c. Okay, now one more thing. If that argument of your trig function, or right, it works for exponential functions, actually pretty much all of our functions, is a multiple of x, so like a k times x, then out in front there's going to be this factor, right, so in front of the antiderivative, this 1 over k that multiplies your antiderivative. The argument of your function is going to stay the same. So if I had the integral of secant squared 2x dx, what we would get out, right, so there's my 2, so I'm going to get a 1/2 tangent 2x plus c. The argument has to stay the same in your antiderivative, but you get this extra 1/2 out in front. And again, if you're still in your Wayback Machine to differential calculus, this is that chain rule, right? We're undoing the chain rule part. Because if we would have differentiated, right, tan 2x, we would have had to have that extra 2 that comes out when we did the chain rule, right? Okay, so these are, right, 2 more that probably you are just going to memorize because that's pretty much what you do. And if you want, right, you could do the other, so you could find for cotangent x, find its derivative, and then you'll know, right, you can integrate that one. And then the same thing for cosecant x. Find f prime, and then what you want to do is you want to integrate what you get from f prime. And then there will be 2 more that you can memorize.